Now, these are actually two different ways of running NannyML, and you could say even running NannyML in production, right? Because even this very like manual, low-level way of running things could be a valid way of actually doing monitoring in production. It's not very automated, of course, but still, it can be valid. And a couple of colleagues or a couple of people from a Belgian company called Radix applied the CMM, thus the capability and maturity model. They applied this this methodology to the field of MLOps, and they're basically trying to formalize the framework a little bit. And one approach that they took is basically applying the 5 levels of CMM to the MLOps models. And the steps that they came up with are the standard ones, So you have a manual process, a repeatable process, reproducible, automated, and a process that actually improves the rest of your flow. And during a meetup earlier this year, we actually went over all of these different levels and looked at how NannyML might apply to these, and in which fashion you could actually do monitoring using NannyML for each of these maturity levels. And it's of course quite logical to think that the higher you go in maturity, the bigger the investment will be, and the bigger for example, the technology stack will be that you require in order to fully gain all of the advantages of that maturity level. So nearly there. So the first level is, as we discussed actually, so running NannyML in a notebook, and you can see a screenshot here of doing that. We basically just import NannyML as a pip package or using Conda. We import it into Jupyter, just run NannyML following the basic steps. So we create a calculator. We fit a calculator on something that we call reference data, which is basically a period in time that reflects how your model should behave. And we use that to kind of like train or calibrate our calculators. And then we use the fitted calculator to calculate, for example, in this case, it is the univariate drift. So in here we have the KS and Jensen-Shannon distance that are being calculated for continuous methods, and chi-square and Jensen-Shannon for categorical methods. You can see that you can also do some kind of plotting, etc. This is all like quite interactive. So that means that most of the time, this is not meant for like a very iterative, repeatable setup. Now, if you go to level 2, you can easily make that more repeatable if you, for example, just take it out of a notebook, or you take the notebook and you just version the thing, right? It's versioned, you can share it. You can basically have people just git clone it and repeat it. It's a very easy way of like gaining the maturity level, etc. The reason why I included it here is because it gives you a nice overview of what the code might actually look like, and we can like quickly just cruise over it. So in the first few parts, you can see that we're reading from an S3 bucket. We're reading reference data and analysis data. Called reference data frame, analysis data frame. We define a couple of column names, and then we set up the univariate drift calculator. You can see that we provide a couple of column names there. We indicate what the timestamp column name is. This timestamp is then going to be used to show to visualize your information on a timeline, which in most production settings makes a lot of sense. And then you can select which methods you would like to be using, continuous and categoricals. We just fit to the reference data, and then we can calculate the actual results. And you can see as well here that these results can then be saved to another S3 bucket, for example. And in this fashion, NannyML can basically become a part of the tool chain that you require for monitoring your machine learning model. So basically, you have one process that makes sure that the model inputs and outputs get collected and get dumped in a fixed place. NannyML can run in an automated fashion, or in this case, you can just run it by yourself in a manual way, and you write out the results into a different location, and you use them as input for the rest of the chain. Now, I'm going to skip a couple of levels here because, to be honest, it's not very interesting, the in-between levels. The most interesting use case is, of course, the level 5, where we can use the outcome of the monitoring process to actually drive results and drive actions within the rest of the tool chain again. So I'll quickly go over this, and then we can hop into some actual code and examples. So the first steps that are always required are basically gathering the values for the model inputs and outputs. And like this is like a very important thing that always needs to be done. This is the bread and butter of what NannyML actually needs to use. So it's quite important to have those collected within your model. We are looking into ways of helping with that. And we were, for example, thinking of having some kind of logging functionality that you can use directly within, for example, something like Fast API or whatever you use to actually host your models as an API. This is like a well-known kind of solution that's also being used by a couple of other libraries within the same space as us. So for example, what you might do here is if your model uses, for example, Fast API, then you can combine Fast API with the NannyML future collection part of the library to enable you to collect the incoming feature values and the outgoing predictions of your model. And then we can store those, for example, using DVC on Git. You can just like throw them on an S3 bucket, whatever works. The intent is to keep it quite lightweight here. Now, as soon as we have collected this information and we have suitable reference periods of data available, then we can fit our calculators and estimators on the reference data, and we can store these calculators for later use. We've just developed this. The functionality to do this is called the store, NannyML store. And basically it just uses a file system, local or remote. So it could be S3 buckets as well, or just a local directory to store your fitted calculators in. And upon running your actual analysis part, it will no longer fit or refit your calculators every time, but it will just use the ones that are available in your own store. And that should provide a significant decrease in compute resources required to run your monitoring part. So we'll be using stuff on the feature store in order to actually fit them, and the resulting fitted calculators can be stored in what is here on this diagram. This is a Google diagram, by the way, can be stored within the metadata store. And then the last step is actually using these fitted calculators and estimators to produce the performance metrics that are required. We can then store these metrics, and we have multiple ways of doing that. I'll give an example of how to do it here. And then we can check for alerts and handle said alerts. And that could be, for example, creating an alert in Slack or pushing data to a webhook, etc. There's multiple ways of triggering these things. And one way to set this up, and that's actually the way that we're gonna look at right now, is basically having NannyML running the calculators and estimators. The results are going to be stored in a database. I put timescale here because it fits very nicely with the use case. Although in the demos, I'm not going to use timescale for this because of, complexity. And it makes sense to just use a regular Postgres instead. Timescale is basically Postgres with some extra additional stuff added on top of it. And then we'll connect all of that to Grafana, which will allow us to visualize all of these results and also tap into um, the actual functionalities that Grafana offers us. For example, concerning visualization and actual alert handling. Right.